Okay, good evening students. Today we will see one more example in the ladder friction. So the given problem is a 7-meter long ladder rests against a vertical wall with which it makes an angle of 45 degree and on a floor. If a man whose weight is one half that of the ladder climbs it, at what distance along the ladder is about to slip? Take coefficient of friction between the ladder and the wall is 0.33 and that between the ladder and the floor is 0.5. So here it is P and Q, and then the angle which is made with the horizontal is 45 degree. The total length of the ladder is 7 meter. So the given condition is the ladder is about to slip, so it is an impending motion. So a man whose weight is one half that of the ladder climbs it. At what distance along the ladder is about to slip? So we have to calculate the distance from any one of the point P or Q. So we will solve one by one. So here the given condition is impending motion, and then the man weight is given as one half of the ladder. So we can assume the ladder weight as W means then one half that of the ladder weight is the man's weight, so that will be W by 2. Anyway, we will solve one by one. So free body diagram of the ladder. So PQ is the ladder, and then we know that the angle made by the ladder is 45 degree, and then the total length of the ladder is 7 meter. So obviously we know that the weight of the ladder will act at the midpoint of the ladder. So it will be 3.5 meter. So next one, they have given us the man's weight is one half of the ladder weight. So it is W by 2. So they have asked the distance from any one of the point. So here I have taken as P point. So from the P point, at what distance if the man climbs, the ladder will slide or about to slide. We are going to find out the distance from P point. So if you are assuming the motion is towards down, because the ladder is going to slip towards down. So this is the ladder direction motion. So obviously at point Q we will have a frictional force, that is Fq. Next one is we will have the normal reaction at point Q. This is because of the ladder and the vertical wall. So now when we come to the point P, that is with respect to the floor and the ladder, because the ladder is moving towards down, obviously at point P, the ladder will move towards left. So if the ladder is moving towards left, then frictional force will be in the towards right, that is the value Fp. And then we know that the ladder and the floor will have a normal reaction, that is Np. So this is the free body diagram of the ladder. So we know very well that F is equal to mu into N. So Fp means mu P into Np. Mu P is nothing but the coefficient of friction between the floor and the ladder. It is given, and it is given as 0.5, and then Fq is nothing but frictional resistance at point Q, that is equal to mu Q and Nq. Mu Q is coefficient of friction between the ladder and the wall, and Nq is the normal reaction. So now we have taken the free body diagram and we know the equilibrium equations. So one by one we are going to substitute. The first one is summation of horizontal force equal to 0. As like previous case, we are taking force acting towards right is positive. So Fp and Nq are acting in the horizontal direction. Fp is acting towards right, so it is positive according to our assumption. Nq is acting towards left, so according to our assumption it is in the negative direction. So we can write the equation Fp minus Nq is equal to 0. And from this we know that Nq is equal to Fp. Fp we have already said that the frictional resistance is equal to, or frictional force is equal to, coefficient of friction multiplied with normal reaction. So we can substitute Nq as mu p and Np. From that we can write 0.5 Np. That means mu p is 0.5 and Np we have substituted as it is. So Nq is equal to 0.5 Np. This is the first equation based on the equilibrium equation number 1. So after that we are moving to the second equilibrium condition. Again we are taking the free body diagram. So equilibrium equation, second equilibrium equation is summation of force vertical is equal to 0, or summation of forces about y-axis is equal to 0, and we are assuming that force acting towards up is positive. So here you can see the force is Np, normal reaction at P, and W which is acting towards down, and W2 is also acting towards down. So normal reaction at P is acting upwards, the ladder weight is acting towards down, and the man's weight also will act towards down. And then the frictional resistance at point Q, otherwise frictional force Q, Fq. So now we are writing the equation. So Np will be positive, Fq will be positive, W and W by 2 will be in negative according to our assumption. So Np minus W by 2 plus Fq is equal to 0. So if you are rewriting this, we will get Np minus 3 by 2 W plus Fq we can write mu Q into Nq. So as like F is equal to mu into N, mu is coefficient of friction and N is normal reaction. So instead of writing Fq, we have written mu Q and Nq is equal to 0. So we can substitute the value of mu Q, that is 0.33, and we can write the equation as Np minus 3 by 2 W plus 0.33 Nq is equal to 0. Further, based on equation 1 and 2, we can substitute the equation 1 and 2. We will get Np minus 3 by 2 W plus 0.33, 0.5 Np is equal to 0. That is Nq is equal to 0.5. When we are rewriting this equation, we will get 1.165 Np is equal to 3 by 2 W. So Np will be equal to 1.285 W. So similarly, you can write Nq also based on this relation, because we know that Nq is equal to 0.5 Np. So Nq is equal to 0.5 times of 1.285 W. So Nq will be equal to 0.642 W. So these relations will be useful for substituting in the next equilibrium equations, so that we can calculate the distance of a man in the ladder. So next one, the third equation we are substituting, equilibrium equations. Summation of moment about P point is equal to 0. We are assuming that clockwise moment is positive. So now we are taking moment about P. So obviously Fp and Np will not create any moment, because their perpendicular distance with respect to point P is 0. So now the first one is W, the weight of the ladder. So we have to calculate the perpendicular distance with respect to P. Is the perpendicular distance with respect to P for the force or weight W. So 3.5 cos 45 will give the perpendicular distance with respect to point P for the force W. So the next one is the force or weight, man's weight, that is W by 2. As like previous, so this distance will give the perpendicular distance with respect to point P for the force W by 2. So this distance, so D multiplied with cos 45. So this 45 degree is nothing but the inclination of the ladder with respect to the horizontal. So that will give the perpendicular distance for the force W by 2 with respect to P. So D into cos 45 degree. That is substituted in the equation. And next one is we are going for the normal reaction at Q. So now we have to calculate the perpendicular distance from point P for this force. So this will be the perpendicular distance with respect to P for the force NQ. So this distance will be calculated based on the 7 meter, that is total length of the ladder, and the angle is given as 45 degree. So we want the vertical component of this, the ladder. So the ladder is 7 meter, it is having an angle of 45 degree. So the vertical distance or the perpendicular distance for the force NQ from the point P will be 7 meter into sine 45 degree. So next one, we are having one more force, that is FQ. So the force FQ will have a perpendicular distance with respect to point P is this distance. So this one will be calculated again with the 7 meter, the ladder length, as 7 meter into cos 45 degree. So in this we have calculated the force multiplied with the perpendicular distance, but apart from that we have to know that whether it is clockwise or counterclockwise. So if you are resisting the motion at point P, that is motion in the sense horizontal and vertical movement, and you are allowing the ladder to rotate. So if you are holding it at point P and then when you are applying a force at midpoint W and W by 2, these two forces, W and W by 2 forces, will make the ladder to rotate in clockwise direction. So it is positive, here it is mentioned. At the same time, when you are holding the ladder at point P and rotation is permitted, so the forces NQ and FQ will make the ladder to rotate in counterclockwise, so as negative. So clockwise moment we have assumed as positive. In some of the book, clockwise moment will be negative, counterclockwise moment will be positive, but we are assuming clockwise moment is positive. So you have to assume correctly and then you have to substitute the values because direction is important. So once you are getting these relations, then you can substitute the relation, that is FQ can be written in NQ. So here we have written as 0.33 NQ, and then we have substituted all the numerical values. So we got 2.47 W plus W by 2 0.707 D minus NQ 4.95. NQ is multiplied with 4.95 minus 0.33 NQ and multiplied with 4.95. After that, if you are substituting NQ is equal to 0.642 W in equation, if you are rearranging and then solving the equation, we will get D is equal to 4.95 meter. So this distance is the distance where when the man climbs at 4.95 meter, the ladder starts sliding as per the given data in the problem. Okay, so we will move to the next one. So this is another problem. You can slowly solve and then you can post your answer in the comment section. Okay, so here the changes are 8 meter long and the angle of the ladder with respect to the horizontal is 55 degree. Then coefficient of friction between the ladder and the wall is 0.25 and then between the ladder and the floor is 0.4. Okay. So next one is a 6.5 meter ladder AB leans against a wall as shown in figure. Assuming that the coefficient of static friction μs is the same at A and B, determine the smallest value of μs for which equilibrium is maintained. So solve and then post your answer in the comment box. All the best. Have a nice day. Thank you.